Welcome back again for our physics class. Friends, in the last class we discussed about energy of a particle executing SHM. In that we discussed about kinetic energy, potential energy, and at last we discussed the expression for the total energy of a particle executing SHM. And after the successful completion of that derivation, we come across expression for time period and frequency of a particle executing SHM. Now, after the successful completion of those concepts, in today's class we will come to know about expression for time period of two things. First one, time period of a simple pendulum, and second one is time period of a spring mass system. So in first year PUC, during the experiments, during the performing the experiments, we have two experiments. First one is the spiral spring experiment and second one is simple pendulum. So simple pendulum is nothing but what? It is consisting of to and fro motion. A bob consisting of to and fro motion. So one bob ಇರ್ತದೆ, ಅದು ಟು ಮತ್ತು ಫ್ರೋ ಮೋಷನ್ ಹಿಂದಕ್ಕೆ ಮತ್ತು ಮುಂದಕ್ಕೆ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತದೆ. ಅದು ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಇದೆ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್ ಅಂತೇಳಿ. ಇನ್ ದ್ಯಾಟ್ ವಿ ವಿಲ್ ಕಮ್ ಟು ನೋ ಅಬೌಟ್ ಟೈಮ್ ಪೀರಿಯಡ್ ಆಫ್ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್ and another one is a spring mass system. So how we will calculate time period of a simple pendulum as well as time period of a spring mass system? So these formulas, or you can say expressions, are very much important to solve the numericals as per as the JEE, CET and NEET is concerned. So please try to remember these all things. Please try to keep all these formulas in your mind, which will be very much helpful in your further classes like PUC second year while solving the problems in KCET, NEET and JEE. So see, what is the expression for time period of a simple pendulum? So expression for time period is given by the equation T is equal to 2 pi into root of 2 pi into square root of L divided by G. Expression for time period is given by, for simple pendulum, T is equal to 2 pi square root of L divided by G, where L gives length we can call, I can say length of the wire, length of the string you can take. ಯಾವುದನ್ನ ನಾವು ತಗೊಂಡಿರ್ತೀವಲ್ಲ ಅದು length of the string, or you can say length of the wire. So G denotes acceleration due to gravity. Acceleration due to gravity. So how much it is? It is always 9.8 meter per second square in presence of on the earth. It is 9.8 meter per second square in presence of earth. So ಭೂಮಿ ಒಳಗಡೆ ಎಷ್ಟಿದೆ ರೀ? 9.8 meter per second square. T is equal to 2 pi square root of L by G, where L is length of the wire or length of the string, G is nothing but acceleration due to gravity. So this expression we will use to solve time period, or use to find or determine time period of a simple pendulum. So ಇವೆಲ್ಲನೂ ನೆನಪಿಟ್ಕೊಡ್ರಿ, ಮುಂದೆ ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗ್ತಾವ. Second one, expression for time period of spring mass system. So to calculate the time period of spring mass system, you can say spiral spring, we will use the formula like this: T is equal to 2 pi square root of m divided by k. T is equal to 2 pi into square root of m divided by k. M numerator bartadri, k is in denominator. So here m denotes mass where we are using in that spiral spring, and k is nothing but what? here K is nothing but a spring constant, we can say. It is nothing but a spring constant. So x is nothing but what? X is heng bartade x anna ನಾವು ತಗೊಳ್ಳಬಹುದ್ರಿ. So x is nothing but what? So x is nothing but displacement, K is nothing but spring constant. So m is mass, K is the spring constant, and here x1 bartadri, x, if x came, then what about x? X is nothing but what? Here x is displacement. After applying the mass, after putting some sort of mass in that pan, there will be increase in its position, there will be change in its position. So that is nothing but you can say displacement. So these two formulas are very much helpful to calculate time period of two different phenomena. We can say simple pendulum and spring mass system. Now, after the completion of these two expressions, we will have some conditions. So which are those two conditions? You are very much familiar. First one is free oscillations, or it is having another name called undamped oscillations. ಇದಕ್ಕೆ ಎರಡು ಹೆಸರು ಅದಾವ. ಫ್ರೀ ಆಸಿಲೇಷನ್ಸ್ ಅಂದ್ರೂ ಅದರಿ, ಮತ್ತೆ ಅನ್ಡ್ಯಾಂಪ್ಡ್ ಅಂದ್ರೂ ಸೇಮ್. ಹಿಯರ್ ದೇರ್ ಆರ್ two names. First one is free oscillations, or in other words undamped oscillations. Second condition is damped oscillations. Third condition is forced oscillations, and fourth condition is resonance. So these are the four important conditions. Please keep these all things in your mind, so which will be very much helpful. So what do you mean by free oscillations? The oscillations which will going to take place in the absence of an external force. In the absence of an external force, the oscillations will take place. So such an oscillations are called free oscillations or undamped oscillations. In the absence of an external periodic force, some oscillations will take place. So such oscillations are called free oscillations, or you can say undamped oscillations. In that condition, in that undamped oscillations, amplitude remains constant, or you can say same with respect to time. In the condition of undamped oscillations, amplitude remains the same with respect to time. So please remember these two things. First thing is what? First point is what? In the absence of an external periodic force, these oscillations can occur. Second point is what? Here in this undamped oscillations, or you can say free oscillations, amplitude is always remains same with respect to time. Next, second one is damped oscillation, exactly opposite to free oscillations or undamped oscillations. So the oscillations which will going to take place in presence of external periodic force. So ಯಾವಾಗ ಎಕ್ಸ್ಟರ್ನಲ್ ಪೀರಿಯಾಡಿಕ್ ಫೋರ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇರ್ತದಲ್ಲ, ಆ ಟೈಮ್ ಒಳಗಡೆ ಆಸಿಲೇಷನ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾವ. ಆ ಆಸಿಲೇಷನ್ಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವ್ರಿ? ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್ಸ್. In the presence of an external periodic force, the oscillations will produce. So such oscillations are called damped oscillations. In damped oscillations, amplitude as well as energy decreasing with respect to time. In the phenomenon of damped oscillations, always amplitude and energy will goes on decreasing with respect to time. Next, in third case, forced oscillations. Forced oscillations is nothing but what? In the presence of an external periodic force, under the action of external periodic force, we have to provide some other external periodic force to that body, then and only then the oscillations will take place. So such an oscillations are called forced oscillations. Hang define ಮಾಡ್ತೀರಿ? How you will define it? Under the action of external periodic force other than natural frequency, at that time the oscillations will take place. So such an oscillations are called forced oscillations. And at last, coming to the point of resonance. So what do you mean by resonance? You resonance anna kaltidri. Resonance andre ಏನು? So see, resonance is basically, it is a phenomenon of forced vibration. Basically this resonance condition will be the phenomenon of a forced vibration. So what will happen in that resonance? So frequency of external periodic force, the frequency, whatever the frequency that will arise in the external periodic force is always equal to the natural frequency. Then resonance condition will satisfy. So resonance condition satisfy because ಏನಾಗ್ತದ್ರಿ frequency of external periodic force always equal to the natural frequency. When natural frequency and external periodic frequency, external periodic force, frequency of external periodic force, both they will be equal, then and only then resonance condition will occur. So these are the four important conditions. First one is undamped oscillation, second one is damped oscillations, third one is the forced oscillations, and fourth one is resonance. What will happen in case of free oscillations, or you can say undamped oscillations? First condition, it is basically the types of oscillations in which there will be no external force. In the absence of external force, these oscillations can occur. In that condition, amplitude remains the same or constant with respect to time. In damped vibrations, or you can say damped oscillations, what will happen? In the presence of an external periodic force or in the presence of external force, the oscillations will occur. So such an oscillations are called damped oscillations. Damped oscillations anta ನಾವು ಕರಿತೀವಿ. So in other words, how we will define it? The oscillations in which amplitude goes on decreasing with respect to time is called damped oscillations. ಮತ್ತೊಂದು ಹೆಂಗೆ ಹೇಳ್ಬೋದು definition? Damped oscillations is nothing but what? The oscillations in which amplitude goes on decreasing with respect to time is called damped vibrations. So amplitude as well as energy goes on decreasing with respect to time. Next, forced vibration andre ಏನು ಹೇಳು? When we are giving the external periodic force externally, by forcibly we are giving the external periodic force under the action of external periodic force other than natural frequency. Natural frequency ಜೊತೆಗೆ ನಾವು ಮತ್ತೆ ಬೇರೆ external periodic force ಅನ್ನು ಕೊಟ್ಟಾಗ ಯಾವ oscillations produce ಆಗ್ತಾವಲ್ಲ ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ರೀ? Forced oscillations we can call. And at last, resonance. So resonance is basically, it is a phenomenon of forced vibration in which frequency of external force is always equal to the natural frequency. When natural frequency is always equal to the frequency of external periodic force, at that time the resonance condition will satisfy. So these are the very much important four conditions which will be very much helpful as far as your further examinations is concerned. Theory, second PUC theory as well as KCET, NEET and JEE. So please try to note down these all things in your notes. When the college will open, I will check these all things, and if you are having the doubt regarding about these all concepts, you can ask me through WhatsApp text, and or I can say you can call to my number. I will clarify your doubts. So with this, I would like to conclude my today's class. So thank you Nana. Have a nice day. Stay home, stay safe.